Welcome back. So, in today's video, we are going to talk about some more important frequently asked questions in System Verilog. Okay, and before going into today's video, if you are new to my channel, please consider subscribing my channel and hit on the notification bell also. Also, please do share this video to all your friends who are also interested to enter into design and verification domain and are doing courses on this particular System Verilog and UVM thing, right? So getting into today's video, in today's video we are going to discuss about some more interesting questions related to system verilog. So the first thing among that is, what is the difference between new square brackets function and new parenthesis function? Okay, so you will see these two functions within your system verilog most frequently. So in today's video we are going to discuss about what is the difference between these two things. So basically, when you're talking about the new with square brackets, so this function is used to create the memory. Basically, when you're creating the array, okay, when you are assigning some values into the array, when you are allocating the memory to that array, you will be using this new function with square brackets. Okay, basically you will use in any of not only here, if you see, we have talked about only dynamic array, but basically in any type of array, in either associative arrays or in queues also, you will be using this square brackets only. Okay, so this new square bracket is used to create a memory in case of arrays, or it is also used to resize the memory for resizing, or else for creating new memory also you will be using this new with square brackets function, right? And then the second thing is new with normal brackets function. So this is the constructor function. If you have seen about the classes, okay, in classes you will be creating the object. Okay, object creation is nothing but creating some space for that, or creating some memory to that particular thing. But in any class, if you don't create the object, if you don't use this new function, you can't create the object. And if you are not creating the object, you can't use that particular class, you can't assign something into that class. So that is why class constructor is very important in case of classes. So this new with normal braces will be denoting that particular function. Okay, so square brackets is used to create the memory in case of arrays, or in order to resize the memory, or in order to copy something into the new array. So in order, this is everything related to arrays. And when it comes to normal parenthesis, this is related to the class constructor function. This is used for creating the objects inside the class. Okay, so basically this is how you will be using this. Okay, new with a new square brackets of 5 means you are allocating 5 memory locations to this particular array. In the same way, here if you see, this is my class, and if you are creating the here I have created the handle for my class, and for this particular handle you have to create the object. If you are not creating the object by using this class constructor function, new function, then you can't assign anything into that particular class. So that is why this is considered as class constructor function. I have talked about this clearly in the class video. Okay, I'll link that in the description box. You can go there and check it out. Right. So this is the difference between new with square brackets function and new with normal brackets function. Right. Now, the second question is, what is the difference between shallow and deep copy? This is again one more important concept in System Verilog. Copying techniques. Yes, copying techniques are really important in System Verilog, and in within copying techniques you are having two types of copies. One is shallow copy and another one is deep copy. Okay, from the name itself you could say that shallow copy means it is not completely copied. Okay, so the data, when you want to copy the data from one object to another object, if that particular data is not completely copied, then that refers to shallow copy. And if that particular data is completely copied, then that is deep copy. Now let us see what is the difference between this shallow copy and deep copy. Like as I am saying now, what is the thing which is not completely copied and what is the thing that is completely copied. Okay, So in shallow copy, why do we use shallow copy? Okay, when you want to copy the class properties, like basically every class will be having properties and methods, is it or not? So when you want to copy the properties of class like integers, class strings, or instance handles. Okay, so basically class consists of these things only, like data types like integers, strings, and everything, which are called as properties, and some instance handles, is it or not? So when you want to copy such things, you will be using this shallow copy. And there are certain things that can't be copied by using shallow copy. So what are those? They are nested objects. Nested objects means, for example, if you are having two classes, okay, like class 1 and class 2, okay, so when you want to copy all the properties and methods in this class to class 2, basically what happens means, if this class itself consists of some properties, okay, so they will be copied into class 2. And here within this properties, within this class, if it is having some others classes properties, like this is class 0, class 1, class 2, so this class consists of its individual properties as well as it consists of the properties of this class 0 also. Then these particular class 0 properties are called as nested objects. Nested means within one thing there is another thing, that we called as basically nested. So that means this class 1 consists of its individual properties as well as the properties of this class 0 also. So basically this class 0 property which is nested in class 1, they can't be copied in class 2. What is the meaning of they can't be copied? That means basically copying is nothing but whenever you're copying something from class 1 to class 2, and if you are making any changes within class 2, those property changes can't be reflected in class 1. Basically that is the like thing of copying, is it or not? So but in case of nested objects, if there is any change that you are making in this particular object, then they will be reflected in class 1 also. Got my point? Yes, if you are copying, if you are making any changes in this nested object, then they can be reflected in that particular class 0 and class 1 also. So that is shallow copy. Okay, here in case of deep copy, this won't happen. That means all the properties of class 1 is copied to a class 2, as well as the nested objects are also copied into class 2. Okay, so basically this is where the difference lies between shallow copy and deep copy. Okay, basically if there are no nested objects, then there is no much difference between deep copy and shallow copy. But if there are nested objects in your class, then those nested objects can't be copied in deep shallow copy, and those nested objects are also copied in this deep copy. How we will do that? You will be writing some custom method for that. Okay, I have explained in detail when I'm talking about deep copy in my video. I'll link that in the description box. You can go there and check it out. Okay, so that is the difference between shallow copy and deep copy. Okay, unlike shallow copy, deep copy performs complete copy of an object, which is not present in shallow copy because nested objects can't be copied in case of shallow copy. Got my point? So this is the main difference between shallow copy and deep copy. If you are still having any doubts, you can ping me in the comment box. Right? Now, the third question is, what are super and this keywords in system verilog? Okay, basically you will be mostly seeing these two things in your system verilog test bench code. Okay, so what is the super keyword and what is the this keyword in the system verilog? Basically super keyword is nothing but, okay, so we'll use this super keyword in the inherited classes like child classes, or we'll call it as derived classes, is it or not? So you will mostly use the super keyword in the derived classes. So why do we use the super keyword is in order to denote the class members of the base class. For example, if you are having base class, okay, and you are having some child class, Okay, in the same way you are having the child class 1, child class 2. Okay, in this way you are having, and you are having base class 1 and similarly base class 2, right? So when you are mentioning the child class with super copy, then that means the immediate base class, because here if you see, basically the base class will be only one. Okay, you don't have many base classes, you will be having only one parent class, and you will be having many child classes. Okay, so when you are referring to the super keyword, that means the immediate base class that is present before the child class, those members will be referred by using the super keyword. Clear? So this is the use of super keyword. When you want to refer to the immediate base class members with this particular child class handle, you will be using the super keyword. Okay, so that is about super keyword. Now coming to this keyword, basically the opposite of super keyword you could say. Basically, why? Because in super, see, super means it will be referring to the base class methods and properties, but this keyword refers to properties and methods of this present class that you are talking about. Okay, that means basically this is the current class instance. When you are referring about current class instance, you will be using this keyword. Okay, so only for generally one important thing about this keyword is that you will be using only this in the non-static class methods. You know, there are two types of classes, like static class and the non-static, and when the class is non-static in nature, then only you can use this keyword. Basically by default the classes are non-static in nature, but when you are referring to static class, then you should use the keyword static before the class. And when you are referring to the static class, you can't use the this keyword in such cases. Okay, that is the thing you should remember, right? So mainly the main usage of this keyword is it will be reducing the confusion for the compiler in order between the differences. For example, okay, let me give you a small example here. For example, if you are using some class, okay, so this is my class and this is my bit 31 down to 0 data, and these are the two properties. Like you will be having int id, so these are the two properties if you consider. Okay, so in the same, so this is my class and these are the two properties within my class. Now for example, if I'm having a method in this class like function new, and in this if I am having some two things like bit 31 down to 0 data comma some int id. Okay, so in this way if I'm having the method which consists of the names which are same as that of properties within my class. Okay, so the properties names as well as the method arguments inside the method names are also same. So basically in such cases, when you are referring to this keyword, that means this refer to this particular values. Okay, that means the values within this particular function, within this method, within that current class instance is referred to as this dot data. That means the data that is present on these two arguments is called as this dot. Okay, so in this way you will be using the this keyword. That means it refers to current class instance. Okay, so this is the use of this keyword in order to, because basically if you see here, why do you use this is, as I told you, in order to reduce the ambiguity for the compiler. That means here if you see, I'm using the same names for the class properties as well as the method arguments also. So now the compiler get confused. If I'm just assigning data equal to data, then the compiler gets confused which is the actual data and which is the property, okay, of the class. So in order to reduce this ambiguity, if you are mentioning as this dot data, then that refers to this particular data, and this dot data is assigned into this particular data. Got my point? So this is how basically you will be using super and this keywords in system verilog, right? Hope you got an idea on what is the super and this keywords. They are also very important in system verilog. And then the next question is, what is the difference between virtual and pure virtual function. Okay, so basically, okay, let us talk about when you are mentioning about the how to point out the difference between virtual and pure virtual function. If you are just using the virtual keyword before the class, then that is virtual function. If you are using the pure virtual, for example, if you are just writing virtual class transaction, so this is basically the virtual class. When you are mentioning it as pure virtual, then that particular transaction is pure virtual in nature. Okay, so this is the basic difference. Now let us see what is the main difference between virtual function and pure virtual function. Okay, so the virtual function, when you are mentioning the base class as virtual function, then its method can be overridden by the classes, by the child class. Okay, that means it will be having some methods and those can be overwritten by the child class, which is having the same function name or arguments. Okay, that means, for example, if you are mentioning the particular class as virtual class, then that base class can be overridden by the child class. Okay, that means virtual means actually that base class is not containing any methods. Only the child class can override this by using their particular function name or something. That is about the virtual function. When it comes to pure virtual function, the main difference is that at least in case of virtual function, you can just you can have the method. Okay, and that method can be overridden by the child class. But in pure virtual method, it is mandatory for methods to be implemented. Okay, because as I told you here, in virtual function, the child class can override it or may not override it. It is its wish, whether based on the interest of the child class, whether or not to override the base class method is the dependency on the child class. But in case of pure virtual method, that is not the case, because pure virtual means that particular function, that particular method in the place base class doesn't contain any body. Okay, it just contains the definition. You will just define something. Okay, there is pure virtual function, and when you want to create the body or when you want to override that function, you should definitely do it in the child class itself. Okay, so that is the difference between virtual function and pure virtual function. I have already explained it clearly in one of my video, where I have explained clearly about virtual and pure virtual differences in the abstraction properties of the class. Okay, I'll also link that in the description box if you still are confused about, because since we are talking about only interview questions, I am just explaining you in that point of view. I'm not going to explain deeply about any of these things because I have already explained it. So I am just going to link those videos. If you want to have a in detailed explanation on this particular function and pure virtual, you can go there and check it out, right? So that is the difference between virtual and pure virtual. Simply speaking, if the particular function or if the particular method has defined, and if it is having some body, then it is virtual function. And if it is only defined and if it doesn't contain any body within the function, then that is pure virtual function. You can just keep that in mind, right? So that is the difference between virtual and pure virtual. Now here is the code again. Here it was you are asked in order to write a constraint. Okay, and that constraint, you should write a constraint in such a way that whatever values that you are mentioning in that constraint, they should be divisible by 5. It is very simple, because by in order to make it divisible by 5, what you will do, value percentage. Here basically percentage means reminder. Okay, so value reminder 5 equal to 0. If you divide with 5 and if the remainder is 0, then obviously it will be divisible by 5, right? So that is the basic constraint. Simple. Okay, so this is about how to write a constraint. Now the next question is how to disable randomization. Okay, this is one of the advantage in case of system Verilog. You can randomize it, and also whenever you don't want that particular variable to be randomized, you can easily disable that particular randomization. Now how are you going to do it? By using the rand mode. Okay, by using the keyword rand mode, you can disable the randomization. That means means, as I already talked about this, so basically by default when you are using the randomization keyword, that means the random packet. For example, if you are doing some packet dot randomize, okay, when you are randomizing it, the rand mode will obviously by default be in 1. And if you want this particular randomization to be disabled, then what you have to do, you have to use this particular as 0. Okay, you have to give this particular function rand mode of 0. That means rand mode of 0 means that particular packet randomization will be disabled. Okay, so again, when you want to enable this particular thing, what you have to do, again you have to convert the rand mode from 0 to 1. Okay, so basically if it is 1, then it is enabled. If it is 0, then it is disabled. By default, when you are randomizing, rand mode will always be 1. Right, you should keep this in mind. So now the last question is it possible to override the existing constraints? That means if there is one constraint and if you want to override it, can you do that? Yes. So basically you can override the constraints. So how are you going to do this particular thing? Okay, by using inline constraints you can do it. Okay, basically in inline constraints you don't exactly override the constraints. Okay, we'll talk about this in the next session while we are talking about inline constraints. I'll explain in deep like what is the actual overriding concept that we are talking about. Does inline constraints really override the existing constraints? Okay, but basically we can say there is some overriding taking place by using inline constraints. And then the second thing is by using inheritance in constraints. Okay, so basically in inheritance you know that, okay, every property from base class will be inherited by the child classes. So when you want to override the parent class properties, you can do it by using the child class properties and methods. Similarly, in inheritance also, it will also by using the child class constraints, you can override the parent class constraints, right? So this is as one is by using inline constraints, and second one is by using inheritance property within the constraints. This I have already explained, inheritance within constraints. If you didn't see that, I'll link that also in the description. You can go there and check it out, right? So these are again some of the frequently asked interview questions in system Verilog. Yes, we will be making some more videos in the upcoming sessions, so don't miss that out also. And also in all these questions, if you are still having any doubts, you can ping me in the comment box. So that is all for today. Thank you.